All right, our goal today is we're going to see if in Arizona they are more inclined to have lighter colored cars based on the heat. So, what we notice here is that there was a random sample done of 300 cars, and the table shows the distribution of car color in the sample, which is represented here in green. And then we also have the distribution based on all of North America down below. So these are two separate figures. That's something to know going into this. We want to see if there's convincing evidence that the distribution of car color differs from what we see in North America. Okay, so what we want to figure out first here is what are the expected values we'd expect to get? So we have 300 cars, right? So in North America, if we did a sample of 300 cars, we'd expect 23% of them to be white. So what I'm going to do is I'm just going to plug into my calculator. 300 times 0.23 gets me 69. What it's telling me is I'd expect to see 69 white cars. I'm going to do the same thing for all of these. Now for black, I'm going to do 0.18 times 300. Some of you might be doing this in your head. That's nothing wrong with that. I always like to plug in the calculator just to be safe. 0.16 times 300 means 48. And then I'm just going to keep going down the road just like so. And what I'm doing here is I'm figuring out that if I did a random sample of 300 cars anywhere in North America, really, these are the numbers I would expect to see based on a sample size of 300. Now, of course, we might see something different. There's going to be variation. We're not always going to get what we expect. That's okay. What we're trying to see is if what we expect is really far off from what we see. That's ultimately what we're trying to test here in this and in our statistical study here. All right. So on first glance here, looks like there are more white cars. There are less black cars. There are less gray cars. And the other numbers are kind of falling in line here. So upon first glance, I'm noticing a difference. But is it a difference just based on sampling? Or is it because that they actually favor lighter colored cars? Okay, so now I'm going to be constructing a null and alternate hypothesis because ultimately I'm going to be doing a chi-square goodness of fit test here. So I'm looking at one categorical variable. That category is the color of the cars. So since I'm only looking at that one categorical variable, I'm comparing it between what I see and what I expect. That's going to be a chi-square goodness of fit test. So I'm going to write my null hypothesis here. Now my null is that the distribution in car color is the same as the North American study here. So we'll say the distribution of car colors in Arizona is the same as North America. And ultimately, what are we trying to prove? We're trying to prove that there's a difference. So that's going to be our alternate here. And let's see. The thing I like about, at least I can do this with copy and paste, I can just take my null hypothesis here. I'm going to copy it, and I'm just going to edit it a little bit here. So instead of having that it is the same for North America, I'm just going to change that it is not the same. It's good to have a null and an alternate that are very similar in wording because it makes it very clear what you're going to be trying to prove here. So I even underlined is not the same. All right, so how are we going to go about performing this? Well, we're ultimately going to do a chi-square goodness of fit test. So we're going to walk through how you can do that. Now, I already did my expected counts here. That's pretty important. What I want to do now is I want to do my conditions. Conditions are always important. I want to make sure that we're able to run one of these. So let's see. I'm going to change the font here a little bit. There we go. Cool. So for my conditions, I'm going to go with, first of all, is it random? We always want to make sure it's random. Let's take a look. They told me it's random right up here. So I'm maybe going to do a nice little arrow here. Check. All right, next one I want to check is my 10% condition. Since this isn't an experiment, it's a sample, I have to check that 10%. Is 300 less than or equal to 1/10 of all Arizona cars? I'm going to go out on a limb and say yes. I'm very comfortable saying it is, so I'm going to just say that. We don't have an exact number, of course, but I think it's safe to say that there are more than 3,000 cars in Arizona. All right, and now for our last one, large counts. Remember, this is based on what you expect, not what you see. That's important. Let's take a look at all of our expected counts. Our lowest one is 6. So I'm going to even just draw an arrow up here. All these expected counts, the lowest one is 6. They are all greater than 5, or equal to. All greater than or equal to 5. All right, so now we can run our chi-square goodness of fit test. We can either do this out by hand or we can use the calculator function. I'm going to lean towards the calculator function to save us a little bit of time here. So I'm going to pull up my calculator. So I'm going to click on Stat and go to Edit. Now let's see, I've got my list. My list, I want to put what I see first. I want to put all the counts that I see. So I'm going to have 84, enter, 38, enter, 31, enter, 46, 27, 29, 6, and do I have any more here? Let me double check. And I've got others, 39, so I'm going to put others down there too, 39. Okay, now what I want to enter in now is what I expected. I see what versus what I expect. 69, 54, 48, 45, 30, 27, 6, and then, so if you go down here, good. And the good thing is you want to make sure that they're all lining up. That's important as well. If these aren't lining up, then it's really going to throw off everything. Get rid of that quick. Oh, 21 was my expected count. It's always good to double check that. Notice how I check that. Always check. Okay, go down to edit. And my last one here is 21. All right. So now I'm going to go to stat. I'm going to go to tests here. And I'm going to go to goodness of fit test. Chi-square goodness of fit. And all I have to do is hit an enter. And you'll notice I get a chi-square value, I get a p-value, it gives me my degrees of freedom as well. If you look at the p-value, it is really low. Again, it looks initially like you're getting something that is greater than 1, but you can't have a p-value greater than 1. So for my chi-square statistic, I'm going to rate 29.921. My p-value is, let's see, 1.528 times 10 to the negative 5th power. Which means that decimal place will be going over 1, 2, 3, 4, 5. Which means it's definitely going to be lower than my significance level. So, what have I proven here? Well, what I've proven is, since, I'm going to just sum it up pretty quickly. My p-value is less than my significance level. I have enough evidence to prove that there is a difference in distribution of car colors in Arizona versus North America. I can always put that I reject my null hypothesis because I did. I didn't necessarily state that in my statement here, but what I just established was I just have proved my alternate, which is awesome. This is cool. I got something here. All right. Now, if you really want to get down to it, you can take a look at your chi-square statistics and look for the largest one. You'll notice that your calculator gives them to you. You want to look for that really high chi-square statistic difference. Now, 3, not too high. 4, somewhat. 6, it's kind of low. You're looking for a number that really jumps out at you. 0, The ones that are 0 don't really... Oh, 15 right here. That's really high. What I'd probably go back to is, now I'd look and see, okay, where'd that come from? It looks like the others, actually. I was not expecting this, but it looks like the other gave us a really high chi-square statistic. We did end up getting some different chi-square statistics as well for white and black, but that's ultimately what you can check out here. Which color gave you the higher chi-square statistics? Because that would give you the biggest contribution. And that gives you a chance to analyze this, because you know that you have a difference in distribution. What got you there? And actually, I did something wrong here. And I'm going to run this again. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 categories. My degrees of freedom was wrong. I'm going to change that now. For my degrees of freedom, let's go back here. I'm going to do chi-square goodness of fit. So I want to change those degrees of freedom to 8 categories. I'm going to do -1. And that gives me my degrees of freedom here, which are going to be 7. And we might get something different here. And that's kind of cool. It gives us a chance to see what happens when you do something wrong. Awesome. Let's see what happens. We're going to calculate again. Enter. We still got a really low p-value. So ultimately, that really didn't change things. We had 9.8 times 10 to the negative 5th power. So I'm just going to change that. But again, watch out for that. The degrees of freedom, sometimes your calculator will do it for you. In this case, it did not do it for me. So that's an excellent error to catch. Watch out for that. But I can still take a look at my chi-square statistics. I still got 3, 4, 6. Those are pretty high. So I could say that those first 3 colors are big contributors, as well as, let's see if the last one, yep, the last one still holds up. So if I were to look at what really led us to, you know, reject our null hypothesis here, it was these first 3, as well as the last one. And if you look here, the expected versus what we saw was quite different for all of these. You would expect a pretty big chi-square statistic for that, or contributor. So ultimately, we made a small mistake here, but I was able to catch it, and it did not change my ultimate conclusion. But always be careful of that. Remember, degrees of freedom, number of categories, -1. Sometimes your calculator will do it for you. In the case, this one didn't for me, so I had to manually enter it in. Be careful of that. So here you go. We just ran ourselves a nice chi-square goodness of fit test using our calculator functions, constructing a null and an alternate, checking our conditions, and then analyzing it a bit. Hopefully this helps you.